Again, I would like to welcome everyone to our last CLF Bay Area event of the year. Today's topic is embodied carbon in affordable housing, and we have 4 great speakers lined up for you. So it should be a good couple of presentations. We won't be covering the basics of embodied carbon today, but we shared a primer document with you for those who may be new to the topic. We also have some additional resources on our website, CLF-SFBayArea.org. I will share both links in the chat box, and I'll now jump into the introductions. Let me first quickly introduce myself. My name is Václav Hasik. I'm a data manager at Building Transparency, and I'm one of the 5 leaders of the Carbon Leadership Forum San Francisco Bay Area Hub. Our speakers today will give you their perspectives on tackling embodied carbon, specifically with some insight into the affordable housing projects. And we'll kick it off with Ruchi Shah. She is from the Tenderloin Neighborhood Development Corporation. Ruchi has over 7 years of experience in sustainability across real estate and consulting sectors. She helps companies reduce operating costs and manage climate risks. And currently, Ruchi is a senior sustainability manager at TNDC, which is one of the largest multifamily affordable housing developers in San Francisco. She leads sustainability in the built environment initiatives for a portfolio of over 50 buildings. Our second speaker is going to be Beth Lavelle. She is a senior associate at Sarah Architects in Portland, Oregon. She's also involved in Sarah's Sustainability Resources Group, which leads Sarah's integrated design approach by providing deep expertise in green building practices, documentation, and policy. She has experience in affordable and market rate multifamily housing projects with Sarah, and she's passionate about discovering synergies between environmental and social sustainability in the built environment. Third speaker, David Marr, is a partner at Marr Structural Design. David has been designing structures for over 30 years. And he also emphasizes sustainable design. His portfolio is varied and includes various multi-unit housing projects. His designs also include concrete, timber, rammed earth, straw bale, and bamboo materials. And recently, his firm was awarded an Outstanding Project Award by the National Council of Structural Engineering Association for the Casa Adelante, which is an affordable senior housing project. And then lastly, our fourth speaker today is Lidran Koo, who is a project executive at Cahill Contractors. He has been with Cahill for over 20 years, working on various residential, including affordable and market rate housing, as well as commercial, educational, and healthcare construction projects. And so that is it for our speakers. Each of them will have about 10 minutes of presentations, and then we will hold about 10 to 15-minute Q&A at the end today. So please share questions in the chat box, and we will try to get to as many as we can at the end. We're also recording this event, and we'll post it to our newly created YouTube channel afterwards. And we will post all the links on our website, CLF-SFBayArea.org. Again, I'll drop those links in the chat box. With that, Ruchi, the floor is yours.
Thank you, Václav, and thank you all for joining us today. I'm super excited to be here and talking about developer perspectives on embodied carbon. So let me quickly share my screen. Does it look good?
Yeah, we can see it. Looks good.
And is it in the full screen mode, or you need me to switch?
Yeah, not yet. If you can put it in the full screen mode, that'd be great.
It's for some reason stuck. Are you able to see the notes, or my screen's frozen?
Okay, let me see. I can share the slides from my computer then.
That would be great.
Sorry about the delay.
I think no presentation is fun without some technical challenges.
That's right. Okay, can you see the screen now?
Awesome. Thank you, Vaslav. So as Vaslav mentioned, I lead sustainability efforts at TNDC, and our main goal is to sort of understand how can we push our efforts in sustainability beyond what we hear, people reducing energy, water, waste. So Vaslav, if you can jump to the next slide. A little bit before I dive into our perspectives about TNDC, we are an affordable housing owner and developer in San Francisco, and we have 43 buildings. This is a little outdated, the graphic, and 11 more in new construction. And when we look at the full portfolio, this means that we have a huge opportunity to reduce carbon, which is sort of our biggest enemy right now as we are facing climate change issues all across. And at TNDC, our perspective is that housing is a basic human right. So building more affordable homes is our first priority, but also we are including sustainability across all aspects of our work. We run after-school programs for the tenants. We also have rooftop gardens and people's gardens to increase access to healthy produce. And really the goal is to sort of support tenants in all aspects of community engagement and sustainability. Next slide, please. So as I mentioned, we, like other developers, we have standard goals on energy and water reduction and waste reduction, which directly impacts our triple bottom line and our tenants' bottom line as well. But with sort of the changing environment around us, we really wanted to focus on carbon and adopt a very specific lens on how can we reduce carbon. So we started with operational carbon goal, which means how to reduce carbon emissions from our building operations, meaning gas, electricity usage. So our goal is to reduce scope 1 and scope 2 emissions. We also decided to focus more strategically on on-site renewables. So every new building that we build is evaluated for solar PV. And then targeting green certifications, irrespective of if a funder is requiring us to do that or not. So when we look at LEED, we want to hit gold. When we look at green point rated, we want to hit maximum levels feasible within the constraints of our budget. And also on a per project basis, we are looking at living building challenge, fit well, depending on how it fits with the type of project. Next slide, please. And furthermore, we have two ambitions. We do not yet have a formal goal. We are still researching on how to make it a goal, but we really want to reduce the use of toxic chemicals in our buildings. Because if you think about it, the population that we are serving already have a lot of health concerns and are vulnerable to climate change impacts. So our goal is to reduce the toxic chemicals used in building materials right from the onset. And then the second aspect is tackle embodied carbon, which means how to reduce carbon, again, from the onset, from design and construction phase. So we are looking at a few high impact areas like concrete, steel, wood, insulation, flooring. So right now our goal is to just focus on some low hanging opportunities, and then as we learn more, formalize that into a goal. Next slide, please. So just, even though we are not covering too much of the basics, but just to get on the same page, through all of our energy reduction efforts, we are reducing operational carbon, which is after the building is placed in service. But from embodied carbon perspective, we are targeting everything that happens before a building is built. So working with our teams on figuring out how can we reduce carbon emissions from manufacturing, transportation, procurement, through design and specifications for these materials that goes into our buildings. So that's the embodied carbon piece. As a sort of first step, we decided to work with one of our architects, Mithun, on a project 681 Florida in San Francisco, where we really on a very high level wanted to understand what are the opportunities for us to reduce embodied carbon. And so they did a whole building life cycle analysis using a tool called Tally. It's a few hours of work, but what we learned, and which is no surprise now as we are seeing this more and more, concrete was our biggest opportunity area. And then a few other are structure, ceilings, finishes, things like that, which just needs a perspective that these are the areas we need to focus on. So that was our very first step that we took. Next slide. So starting with structure, we decided to work with our structural engineers on that project as well as all the other projects that we have in new construction to have a basic conversation on how can we reduce the impacts of concrete. And when we think about concrete, many things goes into making of concrete, cement being the most sort of notorious one in terms of carbon impacts. The manufacturing process is pretty intensive. So we are focusing on how to include more supplementary cementatious materials, meaning less cement and more of other low carbon elements like fly ash or slag, which I'm sure my co-panelists, structural engineers, will talk more about. But as a result of this exercise on 500 Turk project, which actually Cahill is our partner, we were able to reduce 20% of the carbon emissions just by changing strategically the concrete design mixes. This was no cost at all to us. Of course, it was a little bit more of time and effort, but this happened because we started the conversation on embodied carbon. Next slide. The second target area for us is flooring. And when we look at square footage, the amount of flooring materials we use in buildings, it's huge. So again, the 500 Turk project with Cahill, in some of the common areas, initially they had spec'd carpet. So we were like, okay, what's the carpet out there that has the lowest embodied carbon impact? And we used a tool called EC3. It's a free, easy to use tool. It's called the Embodied Carbon and Construction Calculator. And we found Interface, which is a very popular brand, is the one that has lowest carbon impacts. And our architects had spec'd that. But the second step we wanted to take is, what if we totally removed the carpet from the space? And so in this case, we decided to keep some of the areas exposed concrete itself. So we are completely eliminating the carbon impacts from the carpet. Now, I understand this might not be possible in every scenario. Even if you have to use the carpet, I think this tool helps us understand what's the lowest carbon option out there. Next slide. And sort of last two examples I want to highlight on how we are using this approach is we focused on gypsum, which is again used so much in our buildings, to evaluate what are in the same category of products, what are the low carbon options. Generally, we use Georgia Pacific, which has a much higher carbon impact compared to the other brands. They are also used in affordable housing. So it's just a matter of picking those brands with a perspective of carbon. And the last example here, similarly, we approach insulation. We wanted to think about how can we reduce XPS, which is like the most, again, notorious in terms of carbon and chemical concerns too, to start substituting with mineral wool or fiberglass. And it may not happen in all aspects of insulation in your building, but at least we can start focusing on what are some areas where we can make this incremental change. Next slide. So sort of to wrap up, and I know my panelists will be sharing more in details, is to how collectively we can take action. I think really the first step is educating the team about even the concept of embodied carbon, which feels still new in our sector, even though a lot of resources are coming out there. So engage every team on every project, right from the architect to the contractors and all the stakeholders, because everyone needs to understand that an owner or a developer cares about these things. Otherwise, even if they have good ideas, it might not come to the table because they are not aware of it. The second approach that we are taking is start thinking about whole building life cycle analysis. It's not a very expensive exercise. If you do like a broad brush exercise, we are targeting LEED and Living Building Challenge credits, even though we are not targeting full certification, just those aspects to understand where do we start, how do we start. The other element which I have found very helpful is start putting in some language around embodied carbon in design guidelines, in RFPs and material specs. Even though we don't have all the data, I can't say we need embodied carbon at a certain point, but I want us to think about embodied carbon. And the last is start thinking as you go through the steps, target low-hanging, no-cost opportunities, which is more about substitution. We are not implementing really innovative materials at this point, just substituting our choices for low carbon options. There are lots of resources out there like Carbon Smart Materials Palette and other tools which we can share later. So I'll leave you all with that. I hope after this presentation, we think about as a perspective that we want to build better than before. We want to adopt a lens of embodied carbon, even though we may not have the perfect information. So with that, I'm going to pass it off back to the team.
Okay, thank you, Ruchi. Beth, do you want to go ahead and share your presentation?
Yeah.
And again, just to remind everyone, if you have any questions for Ruchi or anyone else, please put your questions in the chat box and we'll address them at the end. Thank you.
Can you guys see this?
It's loading. Now we can see it.
Okay,
All
great.
good.
Thank you. All right, I'm Beth Lavelle. I'm an architect at Sarah. We're a firm of about 180 folks based out of Portland, and we have a branch office in Oakland. And I'm going to talk about, from an architect's perspective, our process and how we're kind of starting to untangle this challenge of embodied carbon, and specifically what that kind of looks like in affordable housing. So our process, how this embodied carbon analysis fits into our overall design process, I'm going to walk through that first. So we start very early on with just an estimate of embodied carbon. We've built a spreadsheet tool, which I'll show you a peek of in a minute. But it's kind of before we even have a building design. We built a tool that helps us, kind of similar to what Ruchi was showing, where are the biggest impact categories? What should we be paying attention to the most? Where's the low-hanging fruit? So we built tools to help us do that before we even have a building on paper. Next, we'll go to kind of a comparative analysis of major building components to help to support decision-making with our client and our contractor team. So this is looking at big moves, big decisions that need to be made early on. What structural system are we using? Things that you can't really, you can't backtrack out of after you've made that decision. So we're pulling out specific components to analyze, again, before we have a full building design. And then once we do have a design, we're moving into whole building LCA and tracking throughout procurement and construction. And throughout all of these phases, like everybody who's doing work in this, it's a constant learning process. We're always feeding back lessons that we're learning on other projects or research that we're discovering throughout, you know, as the industry is evolving and we're learning more, we're always feeding that back into our processes and our methods. So this is a peek of our early carbon estimator spreadsheet tool. We built this really as a way to analyze our entire portfolio without having to do full whole building LCAs, which are really time consuming. This is a really simple spreadsheet tool, and we're using this early on in projects, like I said, before we have a building design. So it helps give us, I think you guys can see, let me get my pointer. It helps give us these kind of big categories. What are we looking at that has the biggest impact, and where can we grab that low-hanging fruit early on in the project? Then we look at comparative analysis. So these are a couple of examples of what I'm talking about. We're pulling out specific parts of the building to analyze just small little pieces. So let's look at concrete versus steel in our structural cores. Let's look at timber versus steel columns and help make those decisions very early on in the project without having to do the time-consuming part of a full building LCA. And this approach has been really effective for us to get that in front of our clients and the decision makers really quickly, so that they have the information that they need, along with cost and all the other drivers. We're getting this up front as soon as we can. And then a whole building LCA, as Rushi kind of set me up great for this. This is when we're looking at the full design, everything that's going in it, with some exclusions for interiors and things that are a bit complicated to model and to analyze. But this is a comparison of a recent project. We're looking at a baseline concrete structure scenario versus a heavy timber scenario. So once we get to a point in our design process and we have a full 3D model that we can work with, we're running that through Tally and EC3 and continuing to track that throughout the development of the project. So a couple of lessons learned as we've been digging into this really deeply over the past year or so. Affordable housing clients in particular have really good alignment with our own sustainability goals. Those are not givens for other types of clients. Particularly, I have a lot of experience in market rate, and this is not a conversation that a lot of our market rate developers are having yet. But affordable housing clients really care about their impact on the environment and how they're affecting the community and the world, really. So it's easier to have those conversations. We kind of have an open door from the beginning. In affordable housing, budgets are tight. So we've seen that this can pose some challenges with mass timber as an emerging structural system. And in particular, when we're doing mass timber, it can be difficult to get FSC certified wood. We know that FSC has the most confidence in the data of the forest management practices and has the most reliable information about the impact of that wood. It can be hard to get on affordable housing projects. Since budgets are very tight, space is really precious. One thing I'm struggling with now on my current project that's mass timber is that timber takes up a lot of floor area. Those columns are really big. We're trying to squeeze down every inch of occupiable space that we can get for living space. So sometimes it can make structural systems like steel look really attractive with much smaller footprint. But we know mass timber is a better for the environment. So that's kind of a conflict in space. And then not specific to affordable housing, but industry-wide challenges that we're seeing on all of our projects that are pursuing embodied carbon reductions. We're, as an industry, we're struggling with getting good data on biogenic carbon and wood sequestration. That data is tough. Evolving methods for tracking interiors and TI projects, again, is kind of an industry-wide issue. Methods for adaptive reuse projects, and then clear end-of-life assumptions and consistency across the industry. We're struggling with this. Everybody's struggling with it. It's going to continue to evolve, and we just have to work through kind of imperfect methods and data right now. So that is what I have for you.
Great. Thank you, Beth. Again, questions will be at the end, but David, do you want to share your screen and go ahead? You can see the.
Sorry, do we have the right screen?
We can see our notes screen. Can you make the full screen mode?
Yep. There we go. How
Looks
about
good.
now?
Looks good. Thank you.
All right. Perfect. Thank you. All right. Great. It's great to be here. I'm just going to jump in because I've got a lot of materials. I'm going to talk about carbon and structures. I want to start with this slide. This is a graphic where we kind of looked at all these structural materials and we looked at them against all these characteristics of cost, durability, flexibility, fragility, toxicity, embodied energy, renewability. Is it recycled? Is it local? And what you see with this is that there's no perfect material. There are no materials that are all green, and there are no materials that are all red. And so what it sets up is a more sort of nuanced understanding of what's going on with materials. And so when thinking about embodied carbon, one of the things I like to do is think about materials by just sort of understanding that all materials have to do a job, and and think of all the materials competing with each other. And so I developed this little way of thinking about it, where we take materials and we segregate by function or the job. We think about longevity. You know, how long is that material going to exist? Look at other alternatives, and then look for synergies, and then evaluate the material and the cost against carbon offsets. So, because holistically, all the materials have a cost and they have a benefit. We've seen a couple of these. This is this graphics. This is from WRNS on a project, the Kelsey Center, looking at the impact of carbon, impact of structures on the overall carbon accounting. So here we've got over 60% in the structure. This is another one of these by EHDD. This is the structural materials, or in this case, 90% on one of their projects. So the takeaway from that is that the structure is a big actor in terms of the carbon footprint of the building. This is a really lovely graphic by WRNS for the Kelsey project. And here they're looking at all the different systems in a building, taking a holistic view and looking at how long these elements last. And so longevity, I think, is a super important factor in this, but you see things like the foundation and the core and the structure is quite long-lived relative to like facades and mechanical systems and contents. So now I'm going to shift gears and kind of get into, it was spoken of earlier, the concrete story and the carbon impact of concrete. First, it's important to acknowledge that the biggest driver in the carbon footprint of structures is concrete, and that includes even wood structures. And the biggest driver in concrete is cement. And so we look at ways of replacing cement. So the basic tools out there are fly ash, can do some replacement. The bigger actor, or the more effective actor, is slag. This is a waste product from steel making. And when you kind of put it all together, what you can look at is traditional concrete. Think of it as a baseline. You can see a pound of a cubic yard of concrete may have about 400 pounds of carbon released in the atmosphere. You add a bunch of fly ash to it, you can reduce it about 20%. You add a bunch of slag, you can reduce it by about half. And so it's really important to just, when we think about in our specifications, is we specify upper bound limits on cement. We go right at it. We don't mess around with cement replacement or percentages or anything like that. We just say, these are the limits that you have to hit by in terms of the contract documents. So let me give you examples of how we would do that. This is from the San Francisco Public Utilities headquarters. This is an all-concrete building. One of the biggest factors here is that the strength of concrete continues to increase over time. And when we typically specify concrete, we think about it in terms of 28 days. And this graph is just showing strength increase over time. So for the foundation of this building, we actually let the concrete, we specified 90 days. So we let it just get stronger and stronger and stronger. By doing that, we kind of looked at the job that the foundation needed to do. When we figured out when the foundation needed to do its job, figured out we could wait a long, long time. And then we were able to really reduce the amount of cement in that concrete because we could wait so long. So this is an example of tailoring a mix for the job that needed to be done. Now, in the elevated slabs, these had to be, in order to hit schedule, you had to pull the forms after 3 days. And so the mix had to be super hot, and it had a much greater extent or greater amounts of cement in it in order to meet that schedule. What we did on this project, though, is we started in partnership with Central Concrete, we treated them as a design partner, and we looked at every element of the building, whether it was foundation, shear walls, or flat slabs, and we figured out what the job that needed to be done and what were the both cost constraints and, more importantly, constructability constraints on that. And then in partnership, reduced the amount of cement to the extent that was practical. And I want to emphasize practical, because in this case, we were able to reduce the carbon footprint of the entire building by 50%. But we did a lot of moves to get it done, and they had to be done again in partnership with the supplier. So the supplier is like the expert that's available to design teams. So finally, looking at this, kind of listing in order of importance, number one thing you could do is get in there and replace Portland cement with slag. Again, slag is reactive, so we'll have mixes that commonly go up to 70%. The next is to think about shoring time, like how long you can let concrete wait. That will allow you to develop leaner mixes. The other thing that's super exciting, we're hoping this becomes available in the market, is carbon sequestering aggregate. There's a couple folks out there doing it, but locally Blue Planet is a firm, and they're essentially taking, they're making artificial limestone and then using that to sequester carbon and stick that in concrete. There's also some strategies to displace concrete, like in this case, Bubble Deck is a product where you purposely build voids into the concrete. And then next, last is carbon cure. This is an industrial process that injects carbon into the uncured mix and makes the concrete stronger by absorbing carbon. And then finally, this notion of carbon maturity monitoring. That's where you put temperature sensors in slabs. This allows the mix designers to be much leaner in the amount of concrete, because if it gets cold and the concrete starts going to sleep, they can rush out and put blankets on the slab and keep the mix from going off. So all of these are moves that you could plan with your concrete specifier to get the super aggressive low cement concrete. Now I'm going to pivot and talk about mass timber and some of the timber strategies that are really appealing right now. This is the Kelsey Center being designed by WRNS and Santos Prescott. It is a project that has a goal of very low carbon footprint. we're looking at mass timber kind of in the floors and in the walls right now. Some of the strategies that I think are super exciting are being able to take mass timber. There's some various forms. They could be composite or non-composite, but the ones that are really exciting are the more sophisticated shapes that are coming out of Europe, and these are not in the U.S. market yet. But what's really going on is we're in the very, very early days of mass timber systems. They're fundamentally not that efficient because think of like an I-joist. They're not maximizing where the material is in the system. So there are more sophisticated ways of getting the material distributed to get systems that are stiffer and stronger but use less wood. So these are really exciting developments that are coming down the pipeline. The other thing that is a consideration is that mass timber is not driven by strength or deflection, but it's driven by vibration. And so again, with any new material that's coming out there, there are new things to worry about. But luckily, a lot of the suppliers now, when they give their load tables, will also give the loads controlled for vibration. But when you have complex configurations, you actually have to do fundamental modeling to develop, to understand accelerations and velocities and do sophisticated studies. Then the last thing I want to talk about is there's some really great innovations coming down the road for mass timber shear walls. And in a traditional shear wall, you have like hold downs at the end of the buildings. What folks have been doing is you can take those hold downs and you can locate them inside the timber wall, and you can get walls to rock and recenter. So rocking walls and recentering walls have been around for about 10 years. We've done them in steel and we've done them in concrete. The exciting ones are taking that technology and applying it to mass timber. The basic notion is you have a rigid block, it has post-tensioning on it, earthquake comes, and then the building realigns after an earthquake. And there's some different ways to dissipate energy and get self-centering. But this strategy of rocking and realigning is what we employed at Casa Adelante, which is the multi-unit housing project mentioned in my bio. And what we were able to do is get a building that achieved a gold rating from the U.S. Resilience Council by employing some of these rocking technologies. This was built by Cahill, and we were able to do this at zero added cost against the baseline structures. So there's some really neat things coming out there. Again, I think we're in the very early days of mass timber and lower carbon buildings. And my last slide, there's a company out there, BAMCOR, that's doing some structural bamboo walls. And we hope these folks can take off. Right now, this is mostly targeted towards single family residential work. In terms of a material that's really good for the planet, bamboo is even much better than traditional timber because it's rapidly renewable. Like in a single season, you can replace the bamboo. So that is it for me. I'm going to turn it over to next speaker.
Yep. Thank you, David. Lidran, do you want to go ahead and share your slides?
Let me share my screen. Let's see. Can people see my screen?
Yes.
Good. All right, great. All right. Thank you. Again, I'm Lidran Koo with Cahill Contractor. And yeah, I appreciate the opportunity to speak today. And so yeah, we're a San Francisco Bay Area based general contractors. We do quite a bit of affordable housing, including working with TNDC and even David Marr. So maybe I'd like to talk about perhaps the from the general contractor's perspective. As you heard, from the developer to the design teams, there's a goals and evaluation done. I think I'll as the GC, we're the ones who want to make sure we can execute the plan and make it come to reality. So I want to kind of share a couple of topics, associated with that, really, to go around to really relate to, around material sourcing, procurement, and planning. Those are kind of the topics that I'm going to focus on related to reducing carbon emission. Let's see, right? So regarding to material sourcing, so as the team we're talking about, I think we have to work hand in hand to work together up in pre-construction, because by the time we get to construction, there aren't as many opportunities anymore. It's limited. So as people suggest the ideas, we do want to work hand in hand with them. Things like talked about material selection, right? Those are kind of up and early. Talked about, hey, I think what you mentioned, hey, we want to include these in the specifications, but I kind of want to make sure that we do it, make it a reality, as in, is there such product out there? Maybe we list all these specifications, but when we asked around and nobody really make the product. The good thing is we want to start the conversation, right? And again, we're trying to push the envelope where we're trying to create demand on that. I think we don't ask these questions, then the manufacturer, they go toward whoever's buying the product, and they, of course, they want to produce what the market demands. So I think that's a very important thing, that we keep on doing this, and during the pre-construction standpoint. And the next thing is the design to minimize material usage, and I think that kind of covered what Davis was mentioning. I'm thinking about the structure, and I think we are actually looking at another project currently, another TNTC project, with the mass timber and CLT cross-laminated timber. I think working with our trade partners, the vendors, for example, there's a possibility, the slab, the density can be increased and really reduce its material. So that's another way of things that being explored to utilize material, and the less material you use, of course, you just cut less trees, and of course that leads to the overall reducing carbon emission. As also talking about concrete, I know, the fly ash and cements and whatnot. I think from our perspective, of course, let's find a way to minimize, the structure itself. The floor thickness slab thickness is there any way we can reduce it? I know, of course, we look at potential, whatever we can to reduce the quantity. I think it correlates to do what we can to reduce the carbon emission. And again, the last one, material sourcing, as I mentioned before, just we want to reach out local vendors and see if there's any way we can get that. But as we all know, not everything is made in the Bay Area. A lot of things are out of the regions and whatnot. But we do want to do our part and explore. Hey, what's out there? So I think that's, as a contractor, we can help reach out, really cover a bigger net from the designer, and hey, we want to include all the vendors so we can all talk again. We want to generate a demand there, so there will be more products down the road that, hey, there's more selection. So I think that's a continuous cycle that we want to keep pushing. All right, let's see, next slide. Procurement. So regarding procurement, again, we want to do our best to minimize material usage. Of course, there's just been a lot of talks about modular. That's a pretty intense way to do it, where you do it offsite with building majority of the building, kind of finish it and then bring it to the site and dropping it in. But I think there's I don't think we should look at it as all or nothing. We want to go all extreme modular. I always like to think there's somewhere in the middle, because anything we do will help, right? So that's why I think the trend that I've been seeing last 10 years, even prefabrication of components, right? So example of wood framing and plumbing. Wood framing, you can see panelized wall systems and floors, and they still built off-site. And I was actually talking to our framing contractor last week, and he was mentioning, yeah, and I did kind of pose that question to him, and he's saying, yeah, you know, the panelized way is really a better way to minimize without creating waste, because they can control a lot better in the factory or the fabrication versus we buy in bulk from a lumber yard, and they deliver all standard sizes, and we do a lot of cutting. I mean, that's how it was done, but I think people are recognizing, hey, you know, there's a much more efficient way to do that. So we're definitely seeing more and more every different kind of aspect, different trades. You're seeing more prefab and then really dropping it into the project. The other aspect is procurement is transportation. I think that's another driver that we're trying to reduce, carbon by really not moving so many times. So I think one thing we always focus when we do the pre-planning with procurement is, hey, just-in-time deliveries. If you can bring it, we don't want to bring it to a local area in a secondary staging area where we have to keep on moving back and forth. I think it's always the most efficient where we just, hey, just bring the material as much as we need it, just bring it, and then we're going to start installing, utilizing it versus moving it around and double handling. So that's something, it translates to cost, but I think for that is still correlation with minimizing, just burning fuel, whatever it needs to make it as much as efficient as possible. And again, I mentioned about local fabrication and factories. If those opportunities are there, we definitely should explore that. All right, next one, and then planning. So pre-construction detailing, and I can't overemphasize on that because it's a partnership, and I think the more we can get these feedbacks, we can incorporate those details versus maybe the design team doesn't get that feedback. They do the best. Hey, that's what they feel can achieve for the job, but yet, in reality, there might not be those selections or whatnot or detail that hinders the process and may not make it to reality. So again, I think that just more focus on the pre-construction that is a partnership that, we as a contractor, we kind of the last person to install to make it happen. We really need to be part up front to help out with the process. Secondly is, BIM's been around, the building information model. But again, I'm just seeing trends. A lot of it for the housing side, MEPs are the big one that, people focus on. Because, if you look at hospitals, medical facilities, and any kind of factory, those they've been doing this because there's a lot more MEP. But now we're seeing even other trades, especially the structure like concrete, subcontractor, they're modeling it also to be more as efficient as possible, build the forms they need, minimize that. Again, I'm just kind of comparing to the old days. They just, again, bring everything in and kind of do quantities, and now just, we'll just have waste, we'll just throw it away, and even build forms as much as we needed. So I'm seeing that trend that all the other trades are picking up, that they're utilizing modeling on that. And maybe related to that, I think, with housing, people, again, it's kind of maybe a cost-driven thing that they feel, if we're building a smaller housing project versus like a 30, 40, 50 unit project versus a 200, 500 unit project, that perhaps that the mentality might become more of just building like a custom home and not as efficient. So even like 30 unit 40-unit project, I think we should really still explore utilizing these technology we have to minimize that. And then utility, I just want to mention that because there's always been struggles, utilizing, this is from the construction perspective, getting temporary power, though we do struggle with that because that's something to put in the planning, really pushing up forefront in pre-construction. Otherwise, unfortunately, so many of our projects that there's been struggles and delays from our local utility company that we have a plan. We need temporary power to build the project, and the project started, we can't do it, and we end up using generators to keep the process going. And that just really, I feel bad that we had to do that and just really go against what we're trying to accomplish to minimize using fuels and clean energy from power. Let's see, okay, and then jumping down to my last slide, just challenges as in from the affordable aspect. I think this has been covered, talked about, available funding, right? So that is a struggle where, hey, a lot of these planning is great, but it does require some front end resources. I do see market rate that it was a bigger project, people are willing to do that because they know it will pay off, but funding is a challenge, especially affordable housing. They get so many funding sources. We're all trying to be creative, but I think that is hard to engage more front-end design. So that's a struggle that we're all trying to be creative to work around. And then again, the other thing is just urban sites. A lot of affordable housing are in populated area and very little lay down space. So that's something we have to work around, be creative from like those transportation things that we talked about, issues, and even from getting rid of waste that we're trying to reduce. The best way is, of course, sorted boxes, but it's just a very challenging way to do that with urban sites. So we all have to be creative about it. So I think I went over my time frame, but I'll turn it back over.
Yeah, no, this is good. Thank you, Legion. We have about 6 minutes left, so not a whole lot of time, but we'll try and get to some of these questions. We had a couple come into the chat box. I saw some answers as well, but let's see the first one. Who regulates the embodied carbon in buildings in California? And who can we push for any form of advocacy, or even as Ruchi mentioned, how can we hold people accountable and find alternatives? So I don't know if any of the speakers have any more notes on that.
I can share a little bit. I hope there was some agency enforcing or looking at these things. Maureen County has adopted, I think, a low carbon concrete code. But I'm hoping our building department, building code folks start focusing on this.
Great. And I think this is. Go ahead.
Oh, sorry. I was going to say, like until we have a carbon tax, it's going to be a challenge. And I think the reality on the ground is that we need to find cost neutral alternatives right away, and just do the work to get cost neutral. And again, the PUC building, we got a 50% reduction, and that was cost neutral. But there was work to get it done in partnership.
Great, that's a good point. I think this also segues into one of our other questions with some of the COVID-19 budget deficits and principal sources for financing, I guess, shrinking or going away. A lot of the times cost is emphasized over sustainable building methods. Are there any of these innovative construction materials and methods proven to contain or lower development first costs? And I know some of this was already answered in the chat, but I think it would be a nice discussion point.
Yeah, I wanted to chime in on this one. I'm currently working on a mass timber high-rise affordable housing project, 13 stories, and we actually just got really great cost information that the mass timber is competitive with concrete for a couple of reasons. The speed of construction of mass timber saves about 2 months off of the total construction schedule. So the contractor is able to do their job quicker, and we can occupy that building much sooner. And the weight of the mass timber is so much less than a full concrete building that we were able to like significantly reduce the ground improvements and foundation systems. So overall, it's, you know, if you just look at first cost, timber is a little bit more expensive, but when you factor in the time and the impacts to the rest of the project, the weight of the building, all of these things, we're seeing it, mass timber is competitive with concrete. And we think that that's probably only going to get better as more people start using more timber.
Just to add one more point on cost, I think that is an argument that we have seen in affordable housing forever, right? It's not new. So I think it's the perspective. Just to share a quick example, linoleum flooring, I've always been said it's way more expensive, but as demand increases, we have seen cost competitive prices to vinyl flooring, which we completely want to avoid in our buildings, and that's what we are trying to do. So it's a matter of like engaging team, contractors going out and doing good negotiation also helps in certain ways.
Great. And I actually have one question myself. I don't think we have any more in the chat box, but I had one question for maybe Lidran regarding to some of these innovative materials like mass timber or even some of the new concrete additives. How do you go about sourcing, you know, some of these materials, and are there issues with a material that is not typically used in a region or not used at all on previous projects from a procurement perspective?
Right. So part of it is, you know, we have to work with the design team, what the parameters are and what we can do. So I think if it's not proven, again, we have to create demand, right? So we have to ask questions. So we have to reach out to concrete plants and talk to them. Hey, this is our objective, the reason why we're asking for these. So it starts a conversation. If it's not established, yeah, they might have to do some R&D and create these products that meets these requirements. So it does take some upfront, but again, if there's more demand constantly asking for it, I think eventually they will you know, work together, realizing that they do want to provide a product that works for everyone. So that's the way to start it if that's not available in the market.
Okay. All right, we have 12:59, so we'll wrap it up here. I would like to thank all the speakers today and everyone who asked any questions. Thank you again for this event, and I hope to see you again at some other CLF San Francisco Bay Area event or even a happy hour. Thank you, everyone. I will be sharing the link to our website